and welcome to our third day of IJS and IPC online conference. And also good morning to most of you, as a lot of you will also be in Europe, I guess. But we really don't know right now from where everyone is watching this conference, as we do have a really international audience and really international speakers, but I'll come back to that in a second. For now, let me please give you some of the usual information we always fit in here. Today in the afternoon, after the last talk finished, we'll do our online conference raffle, so you can win some nice prizes. And also, if you go visit our expo area and talk to our sponsors today, you can increase your chances of winning one of our nice prizes there. And that's basically it. We don't have any program changes to announce as of now, different from yesterday. So everything is on track for today. We are prepared, we are ready for a great conference day with all of you. And now the day will start with Gil Fink, who will tell us about how Israel is using data visualization to fight COVID. Hi Gil, please enjoy your session.
Thank you very much. I will start by sharing my screen, and now then we will drill down into the talk. Okay, so hello everybody, and thank you for joining me today. I want to start the session with a story. March 2020, COVID outbreak in Israel starts, and people are starting to get infected with the coronavirus. And meet Moshe Uziel. Moshe is the chief data scientist of the Israeli Ministry of Health. And Moshe got a request from the users to build a sophisticated application that will show things visually to decision makers. So Moshe contacted Shai Reznik. If you don't know, Shai Reznik is a very known front-end developer in the Angular world. And Moshe contacted him and asked him if he can help. And this is something like a mission impossible to create or visualize patient data to visualize and show the various infection chains and to be able to filter those chains and to investigate those chains as much as they can. So Shai contacted the A team, not this A team, but rather this A team, okay? I don't know if you know all those places, but there are 3 GDE, Google Developer Experts in this list, Elad Bezalel, Uri Shaked, and Shai Reznik, and 2 very known experts in front-end development in Israel, which is Ofer Vishnia and Bnaya Peretz. And this A team started to make it happen, try to figure out how to build such an application. And they chose React and D3 in order to create the implementation. And as you know, they did the magic. And after a weekend, they had a prototype of this solution that they suggested. You can see the video that they recorded to the Ministry of Health, and they send it. And what you can see here is the planes and the people that got from different places and the chains of infections that those people caused. Okay, so this is where I joined the gang. Okay, I'm since March working on this app, and I took this prototype and created a very sophisticated BI, business intelligence application that is being used by decision makers in Israel. Even the Minister of Health is using that application in order to craft or to get the idea of how things are going on with the pandemic in Israel. So if you don't know anything about me, I'm Gil Fink. I'm the CEO of Sparksys. We have only 1 employee, me, myself, and I. I'm a freelancer, but I'm very happy to say that I'm a CEO. I'm both the Google Web Technologies GDE and also Microsoft Most Valuable Professional. These are awards that says that I have a split identity between Microsoft Technologies and Google Technologies. I wrote a book back in the past in 2014 called Pro Single Page Application Development. That book is still being sold in Amazon if you want to buy it, but it is written with a library called I'm not saying it loud because most of the developers, the front-end developers today do not use it, but Backbone was I will say, the first library that people started to use components and MVC inside the front end. So what we're going to do right now, I'm going to talk a little bit about data visualization and D3, which is the library that we used, and also how to work with D3 and React. And then we will take a look at the use case of how we created the application that visualize a chain of infections in COVID-19. So what is data visualization? Data visualization is just graphical representation of data. Okay, most of us will create graphs or tables or maps. This is the main things that can present data. But all of these things, all of these tools can help us to visualize things and to see them in different ways, which then we will be able to understand or make decisions according to the data that we're visualizing. If we'll put things, numbers on the screen, that won't be helpful. But if you are creating a graph or some heat maps or things like that, this is very helpful to understand things like how a pandemic is spreading or things like that. And the most used tool in the web right now to visualize data is D3. D3 is a library. It is data-driven. It's very efficient, and it is controlling your DOM. And well, it was created around 2012, 13, something like that. And like jQuery at that time, which was very known library, it has a Fluent API. So you can see that I can say something like D3, select this container. The container can be a div, a span, or whatever, and append to it an SVG element with some ID. And then I can drill down and do things with that SVG. Okay, for example, I can append a group of elements and select inside that group of elements all the lines and link them to some data source. This is how D3 combined the data to the drawn thing that you are currently drawing. Okay, and then you can see that I can do some attribute changing and things like that in order to visualize some data. So with that, let's jump into first example, and we'll understand how to use a little bit of D3 in order to create a force graph. A force graph is a graph with gravity between nodes, and each node is connected with other nodes with lines. So what you can see here that I already downloaded D3. This is just an HTML file, and let's create our force graph. So at first, when the document is loaded, I want to do something like this. I want to fetch my data, okay? I'm going to fetch all the data. The data JSON here has nodes and links, and you can see that each link has source and target, and each node has some data inside of it with some people data. So I'm fetching the data, and from that data, I'm creating my force graph, okay? Running this function. So let's continue with that, and let's create the first thing, which is If I need to create some data manipulation on the data, and this is something that we had in the Ministry of Health, the data that we are getting isn't in the format that T3 needs. So I will manipulate the data in some sort. Here I'm just copying the data to a different arrays, okay? Nothing more than that, but we had to do manipulation in, as I said, in the application we created. And also I'm creating a few variables with the height and width of the container. The container here is just the div, okay? This div here. And this is what I'm going to use as the surface that I'm going to draw my graph on it. Then I will create a few utility functions to help me, okay? And this is the same thing we did in the Ministry of Health. If I want to represent some colors, I can create a function that is called color and then use it later on as a utility function. Of course, this is just returning some color, but if I need to color a male in different color and female in different color, I can do that. A function that will help me to create the icon that I'm going to use for male and female, class getting the male or female according to the gender, and the last utility function called drag. The drag will help me to create drag and drop functionality in the force graph. So if I'm going to drag some node, that node will move during my drag, and I can move it into different places. So after I'm defining what is going to happen when the drag started or something moved or the drag ended, I can declare using d3.drag function what is going to happen when those events are fired. Now, after we defined everything, let's talk about how we create the simulation, the force graph itself. So I'm going to use D3 force simulation, which is one way to create some sophisticated graph. You can create hierarchy graphs and other ways using different functions. And I'm wiring to this force simulation the nodes that I got. I'm also wiring to the links in the force graph, the links data that I got. And I'm configuring a little bit of the aspects of the simulation, meaning what is X and what is Y, and what happens when two nodes are getting close to one each other, and etc. Once I created the simulation, I can go and just create the surface of the SVG. This is me creating the SVG. Of course, D3 is very good with the creation of SVG. And you can see here that I'm enabling zoom in, zoom out functionality, which we'll see when the application will run. I'm also creating the nodes and the links. So here is me creating all the links, okay? I'm appending the links and creating those. And this part is creating all the nodes, okay? So here I'm wiring the data of the nodes again, and each node will be represented as a circle, and each circle will have a radius and field color. And if I'm dragging this node, then I'm calling the drag utility function I created beforehand. Also, I'm creating a label on the nodes. Okay, so in the label, we will put the icon according to whether the data is a node of a male or a female. Okay, and that's all. And the last thing before we can run this simulation is to create the simulation itself. Okay, so there is a tick event, meaning that the simulation need to do something, then I'm just changing the element's position according to the current position that the drag and drop functionality put on my links, my nodes, and my labels. Okay. With that, if I will save this and run this in the browser, what we will see right now is a force graph with drag and drop functionality. And since my screen is a touch screen, I can go and do things like zoom in and zoom out on the graph. Okay, so in a whole, this is how you can create a force graph using D3, and I hope that you got to understand a little bit about how to use D3. Now, as I said, in our application, we used React with D3. But the main question is, who is steering the car? Who is doing what? Because D3 manipulates the DOM, and React also, React's responsibility is to do DOM updates and things like that. So what we did is React will handle all the DOM, meaning that if the data will change, then we will re-render the entire graph, and D3 will handle all the math and the SVG creation. So let's see how we can wrap the force graph that I created inside a React component. So here in the example, I took the code that we saw previously, and I put it here, okay? It's the same code that you saw me in doing or creating in the first example, but now it's inside a function, okay, that I'm going to use. And this function returns two things. A destroy function, meaning that I'm enabling to stop the simulation if there
So we just had some technical issues. I'm sorry about the interruption, everyone. So please, Gil, you can continue now and it should work again.
Okay, cool. Thanks. I will repeat the last example because I don't know what things you got and what things you didn't got. So we're creating a React component that will wrap the D3 force graph that I showed you in the first example. So how it will work. So first of all, we are going to add a reference using React use ref, okay, to the container that we are going to use later on. Where we are going to use this container? Here, in the div wrapper on top of the D3 is going to be the reference, okay, and there is going to be some style. And as I said, React is going to handle all the DOM manipulation or all the DOM change. So I will use effect, React use effect, in order to understand whether the data is changing, and if the data is changing, to update the force graph accordingly. How it is working, I'm running the function that I showed you here that runs the entire force graph. Okay, I'm running that function again with the current container reference and the data, the links and the node data, and some function that will show us a fancy tooltip. Last but not least, I'm getting the destroy function from the generator here, okay, that will stop my simulation whenever this component is going to get unmounted. So if I'm going to save this example and run npm start, what is going to happen right now is that we will get the same force graph, much more fancier than the previous example, but now it is wrapped with React, and whenever changes to the data are going to come to the wrapper, the the entire graph or force graph, we will re-render again and again. But if there are manipulations that are creating on the graph itself, meaning that I'm dragging or dropping or things like that, then these things are going to be manipulated using D3. So as you can see, it's the same graph that we had in the first example, now with some tooltip, okay? And I can drag and drop it and do fancy stuff with it. With that, okay, let's continue and let's talk a little bit about how do you render massive amount of data. As you can expect, SVG, when you're using SVG, for each and every node, we have at least one element in our DOM. And if there are connections, links, and things like that, they are also creating elements. So in COVID situation, we have massive data source, which is a lot of patients and a lot of people who get infected. So how can we handle this kind of thing? So we found out that D3 can handle some sort of amount of data, but whenever the data content is getting increased or getting higher, then the entire application can even crash because it can't handle that. So we found a solution which we're using Pixie. Pixie.js is a library that enables us to create a canvas and to draw on the canvas things. And we're using Pixie.js with D3. So again, who is steering the wheel when we're using both Pixie and D3? Pixie is going to handle only the canvas rendering, and D3 is going to handle all the simulation and the math that we are using. Okay, I'm not going to show you an example of how to use Pixie with D3, but I'm urging you and encouraging you to go after this session and take a look at Pixie.js. And there are a lot of explanations out there in the internet on how to combine Pixie.js and D3. With that, let's talk about the COVID-19 data visualization and the app that we created for the Ministry of Health. So what are the customer needs? What the Ministry of Health needed from us? They needed us to visualize the infection chain. They also needed us to visualize some aspects of the disease in a force graph. Why is that? To see how things are partitioned and combined according to some forces that we are creating using community algorithms. They ask us to create an aggregate graph that will be represent data who infected who. Okay, for example, an aggregate can be aggregate on cities in Israel. So which city patients infected other cities. Also, they asked for sophisticated filters, and we will see how it works in the application. But a lot of demands, and when we see such a lot of demands, oh my God. So we are still building the app, and we're still creating the visualization, but how it works. So in Israel, there are epidemiologic investigations. Some epidemiologic person is investigating someone who got sick with COVID. And all the data that they are gathering is inserted into the Ministry of Health database, a central database. Each and every hour, there is a process that takes all the data and then manipulate it and put it inside a Neo4j graph database. This is the database that we are using in our application. Then I can use a Python backend to get the data from the Neo4j and present it in our application. In the application, there are a lot of sections. We will see that in a second. Some of them, or some of the components that we created, are hierarchy tree to see and show the infection chains between patients. The force graph that shows partitions according to different aspects, like, for example, the cities or age groups or even symptoms, which is very interesting to see which symptoms are much more, you can see those symptoms which symptoms affect more people and things like that. We have a bubble chart that shows us different partitions like background diseases. This is, it's in Hebrew, but this is the background diseases. This is heart diseases, and this is diabetic and things like that. So we can partition things according to different things and show the data inside the bubble chart. There is the aggregate graph that was created with D3 and Pixie.js in order to show the connections and who infected who from age groups and from cities and from other aspects. And there is a filter panel that uses JSON logic. What I mean by that, we created a panel that enables us to investigate or do some very sophisticated filters. What we're sending to the server is JSON logic. This is the contract between the client and the server is using the JSON logic in order to create Neo4j queries. Last but not least, there is a statistic area that shows a lot of statistics, for example, potential exposures or the amount of time that it took to create an investigation. And with that, let's drill down and let's see that the application in action. I'm sorry if, because it's localized to Hebrew, but I will try to explain what I'm doing during this video. Okay, so this is the application itself, okay? And when you open the infection chain timeline, you can go and look at different things like, for example, all the patients that we currently have in this current filter. There, I filtered the data. Okay, I can zoom in, zoom out, get tooltip about a lot of information about the patient. And I can also drill down into the patient. I won't do that because it's secure data, okay? This is the force graph. In the force graph, we can see relations between different patients. And you will see that I'm going to use in a second the drop down to create different partitions, okay? As you saw in the examples at the beginning of the talk, I have the force graph. I can drag and drop things. Here I'm picking the cities, okay? And you can see which city in the legend, which city has the amount of infected person in this filter. And the force graph will combine all the relevant partitions, as you can see here. And I can, of course, go and look at the tooltips and everything else related to the data. I can also open the bubble chart. Okay, here I'm opening the bubble chart, and according to this filter, I'm checking the age groups inside the application, and then I'm looking at the age groups and also moving from age groups to cities. Okay. This is moving to cities. Okay, you can see that Jerusalem is the black circle in the middle, and Bnei Brak was the second big circle. These were the main cities with the infections at that time. I can use the filter panel, and here I chose to see all the sources that a tourist infected those sources. We had a few tourists that visited Israel and those tourists infected a lot of people. So I can go and do a query like that. And this is a French tourist that came to Israel and infected a lot of people on March. I can also press the aggregate graph and press the cities and get some aggregation. Here I'm picking the city Jerusalem, and I'm pressing the button and I'm waiting that the data will go up. Okay, there is a problem in the video, sorry for that. Okay, so we're waiting until the query will finish, and then I can go and see which cities Jerusalem infected and which cities infected Jerusalem in this aggregation. And of course, there are more things that I can do in this application, but you get the feeling of what's going on. So let's summarize. D3 and React can work very well together, and you could see that we're using both D3 and React a lot in this application. The tech community, the development community can do a lot of magics and create a better world. You saw that the Ministry of Health contacted a few people from the dev community, and they volunteered to help. Okay, this was a volunteer thing and to create a prototype that later on decision makers can use now as a product to help fight COVID-19. And as you are part of this community, you can also do magic as well. And I hope that this use case will encourage you to go and help fight things like COVID or other things that you believe in. With that, stay healthy and safe, and thank you for joining me. If you want to follow me on Twitter, I'm at Gil Fink. And now I'm going to go to the swap cards and see if there are any questions. This is the time that you can go and ask me questions. So.
Okay, thank you, Gil, at first for this great presentation, and sorry again about the interruption we had in the middle. But yeah, there are two questions actually down in the chat by Pablo. The first is, if and how do you reapply the user manipulation drag upon updated data?
Okay, so drag and drop is handled using with the D3 and not with the React. Okay, so I'm wiring event handlers like I did in the example, in the example I showed you at the beginning, and then React is only handling the DOM re-rendering. Okay, so if there is re-render again, the entire graph is created from scratch, and this is something that you need to understand. This means that because the entire graph was recreated, or the entire visualization was recreated, then there are new drag and drop functions wired to the D3 implementation.
This answer. The next question would be if the use of open source software was a requirement given that government money is spent, or did you pick it on your own?
So that's a good question. We picked open source by our own, and we hope to open some part of the application to the public. What I mean by that, the prototype is something that you can see already online, okay? Well, because when we created the prototype, we created it under GitHub, under JavaScript Israel, which is a meetup that Shai Reznik is managing. So inside the GitHub of JavaScript Israel, you can find the source code for the chain of infection hierarchy timeline. Okay, so this is something that you can go look at the code, but without data, because we didn't put any data there, because it's secure data, patient data, and it's something that we can't put online. Hopefully, in the future, as I said, we will ship some part of this application as open source. Okay, but we used open source and we tried. I'm meaning the people who are creating the application, trying to convince the Ministry of Health to give us the opportunity to release these tools out to the public.
Okay, it sounds really interesting, and I guess everyone can also understand why you can't have the real data anywhere on a public repository or something. So it's really interesting to see how the technologies everyone is talking about here are also used for managing our current situation in the world. Because, you know, it's just that what made us not go to Munich, the COVID situation. And it's really cool to see what's going on with it in the background for managing it. So thank you for giving us some insights into your work there, Gil. It's really highly important work you're doing there. And I guess we all appreciate what you just told us. Thank you.
Thank you very much. And as I said, you can follow me on Twitter. If you have any other questions, just ping me there or DM me there, and I will try to answer.
Okay, great.
Thank you.
So for now, I guess it's up to the next talks we're going to have here today. So see you then. Bye.